This is where we're starting. In our math notebook with your partner, a lot of times before we undo something, we practice doing it, right? Because you can undo something better when you've done it. You're going to look at these expressions, and you are going to give the standard form of all of these, okay? So these are factored currently. I want you to simplify these into standard form. Just do number 1, please. Okay, 3x squared is 9x squared. 7x times 7x, 49x squared. X squared plus 8x plus 16. So this is like not new, right? Adds to be b, multiplies to be c. Everybody seen that? Okay, that's true for this next one. This is where I could imagine some people getting some stuff wrong. X squared plus 2x plus 1. Anybody missing that 2x? Okay. Yeah, if you are, my suggestion is this. Adds to be b, multiplies to be c. Okay. So the next one, x squared minus 14x plus 49. And last one, x squared plus 2nx plus n squared. Okay? So, what you're going to see on 2 is you're going to look for the pattern of standard form. We're going to try to get it to perfect square. So look for the pattern in standard form, and I want you to try to undo this, make it look like these. All right? So we're going to go the other direction now. Look for a pattern first. So what do you why do you think they are called perfect squares? Who'd like to give me what they think the first one would be? Emmett.
X plus 3 squared.
All right. Adds to be 6x, multiplies to be 9. Sweet. Next one, Grant.
Is that x minus 8 squared?
Let's check. Adds to be negative 16, multiplies to be positive 64. Check. Last one, Hatley.
X plus 1/6 squared.
Let's check it out. Adds to be 2/6, which is 1/3. Multiplies to be 1/36. Awesome. So I'll give you a second. I see a couple people jotting that down. Next, we're going to put this to work. I'm going to show you 2 methods we have used to solve when we have not been equal to 0. When we haven't been equal to 0, what's the first thing we have been doing? Getting it to equal 0, because that's where that would say this is where it crosses the x-axis, right? But really, if it's like equals 25, we're looking to see where it crosses at 25. Let me show you what I mean with that while some people are still writing down. So if there's like blah, blah, blah equals 25, really what we're looking is this is 25. We're looking for where the parabola crosses this, correct? But when we minus 25 from both sides, what we're doing is we're reestablishing that spot as the x-axis. Everybody see what we're doing there? Like the big idea, when we're doing that, we're reestablishing that as the x-axis so we can find the x-axis. Well, we're about to add a tool to our tool belt where we will not have to reestablish that at 0. So check out these 2 methods. By the way, there's your perfect square. We already know. Okay. There's Hans' method and there's Jada's method. Hans' method is what we had been doing, right? So check out Hans' method. We distributed. We set it equal to 0. We factored. And we got our 2 answers using the ZPP. You guys have seen that, right? Right? Again, point it out. Look at standard form. Got to equal 0. Refactored. Use the ZPP. Now check out Jada's method. Who can explain to me what Jada did? Finn?
She squared both sides.
Square rooted both sides? Yeah. What's cool is I like that you guys are seeing that, probably because we used the square root method to solve. Kind of what I see is the same thing but different. I see whatever is in here needs to equal 5 or negative 5 to be true. Is everybody seeing that? Because what's 5 squared? 25. What's negative 5 squared? No, negative 5 squared is positive 25. So that means that x minus 6 can equal both 5 and negative 5. Oops. Which means 11 and 1 are the numbers that satisfy that. If you're not just seeing that, don't be afraid to, solve your equation like this. There it is. Okay, so I want you to try Jada's method for those 4 problems at the bottom, please. Eyes up here, mouths closed. Who's going to help me set up that first one? I'm going to do all the work over here and then erase it between, so make sure you're writing down. All right, Grant.
You have to get
What can y minus 5 equal?
It can either equal 12 or negative
What?
2. Oh, I mean 49.
Nope.
7.
Test. It can equal 7 or negative 7. Because if I square those, I'm at my 49. Everybody see how I got these?
Yeah.
Okay, so that means y equals 12 and negative 2. Now always go check it. 12 minus 5 is 7 squared is 49. Check. Negative 2 minus 5 is negative 7 squared is 40. Check. Do you prefer Jada or hands if it's a perfect square?
Jada.
Yeah, only if it's a perfect square. Yep.
Jada, of course.
All right. Who's got that x plus 4 one for me? What are my two things I'm going to set up? Ellie, what can x plus 4 equal?
X plus 4 either 3
3
or negative 3.
or negative 3. And that means x can equal negative 1 or negative 7. Let's test it out. What's negative 1 plus 4?
3.
3 squared? 9. What is negative 7 plus 4?
Negative
3 squared? 9. Check. All right, everybody's good? Okay. The Z1. Hadley. What can Z plus 1/3 equal?
C plus 1/3 equals 2/3 or negative 2/3.
Yep. Which means Z can equal 1/3 or negative 1. Now, if you're not just seeing those, right? Don't be afraid to subtract 1/3 from both sides. Don't be afraid to subtract 1/3 from both sides, okay? If you're not just seeing it, don't be afraid to do the one step. If it's extra work, but you're more likely to get it right, the extra work is worth it, right? I mean, I wrote those little 1/3 and I'm just barely sweating. So it's not too hard, okay? Just barely sweating. Grant knows what I'm talking about. It's not actually hard to write stuff. All right, last one. Oh, no, decimals. No, it's fine. Decimals are just numbers. All right, Raymer.
So
What does v minus 0.1 need to equal?
0.6.
0.6 and negative 0.6 because that squared is 36, which means v can equal 0.7. Excellent. And it only works if this number here is a perfect square. Okay? That's the only way it works. Has to be perfect. All right, lesson summary. You're going to show it to me? No, you're not going to show it to me, but you are going to do it before you grab your homework.